So, you want to learn about AI. What does that even mean? If you stick one toe into the ocean of AI knowledge, you will quickly find yourself drinking from a fire hose of information. That's how crazy it is. And it's changing so fast every day that even experts in this field have a hard time keeping up. I help companies figure out their AI strategies, and I've been giving a talk lately that is meant for executive teams and software engineers, mid-level managers, frontline people, really anybody, students even, to help them get a lay of the land of the AI landscape, kind of an overview of the terrain as it exists right now, as quickly as possible. So it's a very condensed kind of version of all the stuff out there because there's so much information. It literally would take years to become an expert in all the parts. You don't need to become an expert in all the parts. You only need to learn about certain parts that are going to affect your job or whatever you're interested in. But first, you kind of need to see a larger framework. So that's what I'm going to go through in this first video in this series of several videos. The first one shows you the roadmap, what I call the AI knowledge stack. I'm going to go through the stack really quickly, and then I'm going to break it out which chunks you should pay more attention to and drill down in depending on who you are and what it is you want to do. In the subsequent videos, I drill down into each layer of the stack and go into more information about that section of it. Now, if you're interested in AI in general and you really want to get a very good grounding in kind of all of the basics, I recommend watching all of the videos in the series, and that will really give you a good overview of kind of all of the main important ideas in AI right now. If you don't want to do that, if you have limited time or you just want to focus on one area as it relates to maybe your job function or your goals or interests, then I will direct you to that specific video so that you can just pay attention to that part of the stack. So, you want to learn about AI. Where do you start? First, let's go over some basic terminology. Artificial intelligence, or AI, is any technology that is used to mimic human intelligence. There are many types of AI, but we're going to focus on one of these types of AI called large language models, or LLMs. And these are what's getting most of the attention in the press these days, like ChatGPT, Claude Opus, Gemini, and other models. Let's talk about where LLMs fit into the broader category of AI in general. The blue circle here represents all different AI technologies, even things going back to the 1950s, like simple computer programs that can play tic-tac-toe and checkers. Back then, programs were hard-coded with all of the rules built into them by the programmer. But for most situations, there were just too many rules required, and it was very difficult and complicated to create these programs. And so clever researchers figured out ways to let the programs actually learn. And this is called machine learning, where you don't actually code every rule that you want the program to learn. Instead, you create an algorithm that is capable of learning based on being fed data. Within the world of machine learning, there's a particular type of AI called deep learning. And deep learning involves machine learning based on what are called neural networks, or neural nets for short, which are meant to very roughly approximate what is going on in the human brain when we learn things. Now, within the world of deep learning algorithms, there's a subset which are capable of actually creating things. And these are called generative AI because they generate things. And one of the most famous examples of a generative AI model is a large language model, or LLM. There are many other kinds of generative AI models. There are models for creating images, which are usually based on something called a diffusion model, models for creating video, music, drug design, 3D models, voice cloning, novel proteins, sound effects, all kinds of things. And increasingly, the best LLMs are what are called multimodal, which means they involve more than one modality. For instance, large language models that can also generate or look at images or sound recordings or create speech. So now you know where LLMs fit into the larger AI landscape. Let's go back to our original question. So you want to learn about AI. Where do you start? As I mentioned, we're going to talk about what I call the AI knowledge stack. It's basically all the layers of things you could learn about if you wanted to learn about all the stuff going on in artificial intelligence. Again, large language models and how they're being used and the impact they're having on society. At the bottom of this stack are math and a programming language called Python. It is possible to use other programming languages, but Python is by far the most commonly used. And then at the top of the AI knowledge stack, we have the policy, regulation, and social impacts that large language models are having. So you see things in the news like White House executive orders asking companies to register large language models with the government, or Congress passing legislation banning the sale of advanced chips to China to try and keep them from getting ahead in the AI race. Or questions like, will AI take my job? Or will AI cure cancer? Or will AI kill us all? So at the bottom of the stack, we've got math and programming. And at the top, we've got White House executive orders. What's going on in the middle? How do we get from there to here? And more importantly, what do you need to learn? Where do you focus your limited time and attention? And now comes a really quick run through of the entire stack so that you can see the whole framework or the whole landscape in one 100,000-foot view. As I mentioned, at the bottom, we start with math, programming, usually in Python. And with these sets of tools, people build deep learning models. Again, deep learning refers to machine learning models that use neural nets and lots of data to learn. These deep learning models get combined together in something called the transformer. It was invented in Google in a famous paper published in 2017 and was really the breakthrough that led to the modern large language models that we all use today. Well, some of us. So these transformers are used to train large language models, LLMs. Now here I add this white line in the stack to help separate things, which will end up being important later, and we'll come back to it. Once you have a trained large language model, such as a ChatGPT or Claude Opus or Google Gemini, then there are all of these techniques and technologies that can be used to enhance that model to do specific things. And once you've done that, developers can build applications based on those models using a whole bunch of different tools that they have at their disposal. And once you've built an application based on one or more LLMs, you want to make sure it's behaving in the way it's intended. And the field of getting AI or AI applications to do what we want them to is called alignment, which basically means we're aligning the machine's behavior with our intentions. And this idea of AI alignment refers to the simplest chatbot all the way up to artificial general intelligence, which is the idea that one day AI will be as smart as people at anything people do, or even the idea of artificial superintelligence, which means much smarter than all the people on Earth combined. And the idea is, if we ever actually build that, we want its behavior to be aligned with human beings' interests, for obvious reasons. Once you've got your application behaving the way you want it to, then it's time to deploy it to the real world where people can actually use it. Now, this is very similar in many ways to deploying any software for the world to use, such as a web application or a mobile application, but there are some special considerations with AI, in particular, the cost associated with using the AI when people, for instance, type a query into ChatGPT and ChatGPT spits back an answer. That's called inference. And inference costs, for right now anyway, are quite expensive. And so one has to be careful when deploying AI applications at scale to make sure that their high compute costs don't break the bank. And here we've added another white line in the stack to break things up. And again, we'll come back to that later. Next in the knowledge stack is end user tools. This refers to all of those applications that I was talking about, with the most famous example being ChatGPT, the chatbot. It could also be any application that's powered by ChatGPT or some other model using its API, or websites you might be familiar with for generating images or music or video or anything else. Examples being tools like Midjourney for images, 11 Labs for voice cloning, or Udio for music. Next level up in the knowledge stack is industry news. And there's so much industry news breaking all the time that it's basically a full-time job just to try and keep up with all of it. In the subsequent video in this series that covers this portion of the stack, I will give you recommendations for how to whittle that list down to make it something manageable that you can keep up with. There's some overlap here with the next layer because some of that industry news bubbles up into more mainstream news. And this layer involves the legal environment and the risks associated with AI, both deploying the technology and using it. And finally, we're back once again to the top of the stack, and this layer involves the policy regime, the regulatory environment, and the societal impact that these technologies are having as more and more people use them and fit them into their workflows and daily lives and try to figure out how to make sense of them. So that's the quick overview of the stack. Now I want to give some guidance about where you should focus based on who you are and what you want to do. So where should you focus? Because each of these layers builds upon the layers beneath it, it can be difficult to know exactly where to start if you want to learn about AI for yourself. As I said before, it depends on who you are and what you want to do. First of all, this one layer here, end user tools, everybody should pay attention to these. Everybody, no matter what your job, should be playing with these tools, working them into your lives, your workflows, getting used to them, figuring out what they're good at, what they're not good at, what you can depend on them for, what you should not depend on them for, how to double check their work. I'm speaking, for instance, of LLMs that oftentimes say things that aren't true. These are called hallucinations. Some different models are better at answering some questions than others, and the only way to really get a feel for that is to experiment and play with a few of them. I'll go into deeper detail into this in the subsequent videos, but for now, the main idea is that everybody should pay attention to this layer of the stack, because as the saying goes, which you may have heard by now, AI won't take your job, somebody using AI will take your job. If you don't want somebody using these tools to take your job, you probably want to learn some of these tools yourself. All right, with that aside, starting at the top of the stack. Broadly speaking, the people who should be paying attention to this section the most are decision makers, non-technical knowledge workers, and investors. And by decision makers, I'm referring to, in business, executives, managers, entrepreneurs, and outside of business, perhaps policymakers and other government officials or people involved in nonprofits and so on. With the main idea being that these levels of the knowledge stack are kind of where these technologies interface with the real world. And if that real world is where a lot of your time and energy or job function, for instance, are focused, then this is where you should be looking first before you start drilling down, looking under the hood to see how the stuff actually works. Unless you're just interested in that. And it's quite fascinating, actually, but that's kind of different than something that you actually need to know for your job. Now, I want to add a special case here for CEOs, legal, marketing, and product people within companies, possibly a few others I haven't thought of, and that is to learn something about alignment. And the idea there is that these people who have to focus on the real-world effects of these technologies need to be able to poke at them, and see if they can break them, maybe identify problems, which can then be fed back to the developers to fix them. You don't need to learn how to fix these problems. That's the developer's job. But they might not be aware of all of the cases or situations where a misaligned or strangely behaving large language model might do damage or cost the company money, for instance, or hurt its reputation. So in a lot of organizations, people in these types of roles might want to consider getting involved with quality assurance processes to make sure that all of your bases are covered. Next up is a CTO, Chief Technology Officer, and senior engineering roles. These people obviously need to know a lot about the technology that's going on under the hood. They also need to be paying attention above that line to industry news and the tools. Again, everyone's looking at the tools, but industry news in particular, because this is just going to help them understand where things are headed. And they need to be fluent in these areas of the stack so that they can manage the people who are working on that stuff. So CTO, VP of engineering, and so on need to understand, of course, a lot about deployment. They need to totally understand what's going on with alignment, and they need to be well aware of the tools that the developers are using. Most of them probably don't need to become very well versed in the techniques of the enhancement. Maybe I've grayed it out, but I've still made it sort of gold behind the gray screen there. And by that, I'm suggesting that they become conversant in these technologies so that they understand what the engineers are dealing with and the large language model experts when they're working on refining these models and enhancing them. And again, I go into a lot more detail on all of these layers in the subsequent videos in this series. I'm just kind of glossing over it here. But suffice it to say that this is a somewhat specialized role. It's not going to be something that every software engineer knows a whole lot about. More and more software engineers are learning about it. But that's because the field is so new that there aren't a whole lot of specialists yet. but it is a specialized role, and more you're seeing companies hiring AI engineers, or more specifically LLM engineers. And then for most developers, if they're going to be involved with these kind of applications at all, I recommend they pay some attention to the industry news. And that's because some of it they certainly need to know about, for instance, new models being announced and that sort of thing. And then some of it is less important, such as boardroom drama and other scandals. The scandals are kind of fun, though. Now, as I've said, everyone should be using these end-user tools, but developers in particular really need to be playing with them a lot more, just so they can see what's going on out there. And then everything in the middle here, which is basically from fine-tuning these models all the way up through deployment. This is building applications. This is what developers do. I also want to point out the Python down here at the bottom. Not all developers know Python, and while Python is virtually essential for this bottom part of the stack here, for actually building large language models in the first place, it's not absolutely essential for every part of application development, because most applications are not built in Python, but some of those Python libraries are going to help them do stuff that is very specific to dealing with large language models. And honestly, learning a little bit of Python, it's not a difficult language. Any good developer would have no problem picking up the parts they need. In fact, many of the Python tools at this level really only require an intermediate level of proficiency, which would require very little effort for most experienced developers to add to their toolkit. Next group is entrepreneurs. And entrepreneurs basically have to know a little bit about everything. It's just like in the same way that when someone starts a company, he or she needs to know something about marketing, something about sales, something about accounting, something about the law, etc. Same too here with large language models. If they're going to be part of the business, entrepreneurs wear a lot of hats, and that applies to the AI knowledge stack as well. Now, I realize that there are plenty of non-technical entrepreneurs, and they might not be doing any development at all, in which case everything below this white line here, this middle chunk, and the Python down at the bottom, they wouldn't need to worry about that. But whoever they are working with to develop their technology, if their product or service involves large language models, not all businesses do. Increasingly, more and more will, however. And if they do, they will need to get these skills covered, whether it's through hiring somebody or a co-founder or partner, or hiring the services through either freelancers or a software development company. And finally, data scientists and LLM researchers. These people are the ones who really need to understand what's going on with this stuff at a deep level, all the way from the very bottom, the math, the deep learning, the transformer, training models. And fortunately, most data scientists already have a lot of this knowledge, or they wouldn't be data scientists. Many, if not all, will have some knowledge of deep learning. And from there, it's a reasonably smaller effort to learn something about transformers and the training of LLMs. Even if they won't be training their own models, it can be helpful for them to really understand what's going on under the hood and how these things work. In particular, so that they can help the engineers with this layer here when it comes to enhancing the models. And finally, notice this level up here. I've highlighted this industry news, and I've added the word research, because that's really what the data scientists and the researchers, they need to pay attention to the research that is always coming out in this field. New research breakthroughs, of which there are many all the time, may help them directly in their work, but even if it doesn't, it can definitely help them predict what's coming down the pike. So back to these white lines I mentioned earlier, breaking the stack into thirds. Now, at the risk of oversimplifying, the bottom third is for scientists. The middle third is for engineers. And the top third is for everyone else. Or if you prefer another way of looking at it, the bottom third focuses on extending humans' knowledge about how AI works. The middle third is about building upon that knowledge. Applications, really any technology, the things that in theory make our lives better or make our companies operate more efficiently. And the top third is about the usage and the impact of these technologies. So that's part one of the AI knowledge stack. In part two, I'll be going into more detail into the top third of the stack, and I'll be sharing with you the resources that I use for learning about and staying on top of the news with respect to everything that's happening in AI at the more business level, and in particular, how to stay on top of all of the new tools that are always coming out. And there are so many sources to choose from. The emphasis there is actually on picking out just a couple that do a really good job of covering the stuff that you need to know without drowning you with a bunch of information about stuff you don't really need to know. Part 3 in the series will drill down into the middle third, the engineering portion of the stack, where I'll be providing you with the framework for learning about building applications on top of LLMs. That includes stuff like fine-tuning, prompt engineering for developers, retrieval augmented generation, deployment, alignment, all of that kind of stuff. And then part 4 will cover the bottom third of the stack, the data science portion, for those of you who are really interested in understanding how the AI works. Most of my strategy and product work is more at the application layer, but I have personally found this stuff in the data science area to be very interesting and, as I mentioned earlier, helpful for developing an intuition about where the technology is headed. If you'd like me to talk to your team about the AI knowledge stack, then drop me a line at greg@latentspaces.ai. And if you find any of this helpful, please feel free to hit the like button and be sure to subscribe so that you can be notified as soon as the other videos in the series drop. Until next time, thanks for watching.